about what we talked about with classifying systems. I feel like it was kind of a little sloppy on the other note sheet. So just to kind of recap what we talked about with classifying, remember if you have lines that cross at one spot, that's called an independent system. And for that to happen, you have to have different slopes, but the y-intercepts really doesn't matter. But parallel lines have zero solutions, so in the classification of that is called inconsistent. That's where you have the same slope but different y-intercepts. And then if you have like the same line, like it's overlapping, you have an infinite number of solutions, and we call that dependent. That would be where you have the same slopes and the same y-intercepts. Basically, you have the same exact equation, so it gives you the same line. So these are how we classify systems. Today we're going to be looking at, instead of the graphs, we're going to be looking at it algebraically. But you want to keep in mind the three situations above. I mean, usually when they give you a problem, it's usually like that first case where it's independent, it has one solution. But it is possible when you're solving these to keep in mind that sometimes you will have no solutions, or sometimes you might have infinitely many. So if you're solving and something kind of strange happens, like maybe your variables cancel, or you get something weird like this. So if something funny happens, just kind of keep in mind, it might be one of those special cases where maybe it's inconsistent or dependent. So always kind of keep your mind out, but a lot of times they just give you problems that are independent or have a solution, but it's not always going to be the case. And I try to include some on the notes so we could see that. There's two ways to solve systems. The first way is substitution. Basically, you got to solve for one of your equations, like one of the variables, get it by itself, and then you're just going to plug it into the other equation. So personally, I'm not a huge fan of substitution unless I already have an equation that's solved. Because if it's not already solved, usually I just use elimination. But it's up to you. If you really like substitution, you can use that. But I will ask you, like when we do test service, to at least be able to do each method at least one time, but then you can kind of choose what method you prefer for the other problems. And sometimes problems kind of lend themselves to a certain method. But so let's kind of go through this. This should be review. But let me know if you do have questions or if something's not making sense. I don't know what's going on with my screen today. It's like not being super responsive. But for this first example, we have 2x plus 3y equals 12, y equals 5 minus x. See how your y is already by itself? So that means we can substitute, why is it not rated? Okay, let's try that again. But we can substitute this 5 minus x in for our y. So we'd really have 2x plus 3, and we're going to substitute that in for our y, equals 12. I should have given myself way more space, or I should try and write smaller, but here, let me try and write smaller. And I'll zoom in a bit. All right, so sorry, we would have 2x plus 3 times 5 minus x equals 12. So we just need to kind of clean up this left-hand side. So that would really be 2x. We could distribute. So that'd be plus 15 minus 3x. So then you can combine like terms. So that would really be negative 1x plus 15. So you could subtract the 15. So we'd have negative 1x equals negative 3. Divide that over, but you should get x equals 3 for your answer, for your first part of your answer. Remember, when we're finding our solutions, it's a coordinate on the graph, so you're going to have an x and a y value. But to get our other one, we just want to substitute this back into one of the original equations. Usually it's easiest to plug it into the one that's already isolated. So if I plug this in for my x, I would really have y, equals 5 minus 3. If I plug that in for x, so I would just get y equals 2. And I'm okay if you leave your answer like that. If you want to write it as an ordered pair, you could write it like this, but personally, I don't mind unless they say write it as an ordered pair. It doesn't bother me if you leave them separate or together like that. But if they ask for an ordered pair, obviously put them together. But if it just says solve, I don't know, it's kind of up to you, at least in my opinion. So This first example is a good example. I mean, is a good problem where substitution would be a good method because you already had y equals. But if you really like substitution and it's not in that form, for example, the second problem, you could solve one of your equations. So the bottom one's pretty easy to solve. You could just add the x over. So you'd really have y equals x plus 3. So we can substitute this in for our y. So then we just got to clean up that left-hand side. So similar to the last problem, distribute. And a little low in space. But here's kind of like where I said things can kind of go weird. Like, see how negative 3x plus 3x is just going to cancel out? So I'm left with 9 equals 4. So if you end up with a switch situation like this and you get a statement that's not true, like clearly 9 is not equal to 4, that's not true. So since this does not work, what this means is that there are no solutions, or basically what we have is that this is an inconsistent set of equations. Basically what you would see if you solved all these for y, you would see basically we have parallel lines. Like if you sketch these really quick or put them in like Desmos, you would see you're going to have parallel lines. So remember, parallel lines are inconsistent, or you have 0 solutions. So that's what it kind of looks like algebraically. If you're solving and your variables cancel and you get something that's not true, like for example, we got 9 equals 4, that means there's no solutions, or you could classify it as being inconsistent. So usually like when you first learn about systems, you would just write no solutions, but a fancier way to say that would be to say that the system's inconsistent. That would be the, I guess, the quote unquote more intelligent answer. I guess if you want to sound a little more sophisticated, you would say that you have an inconsistent systems of equations because of that. We'll see an example of it, but say for example, we got 4 equals 4, something that's true, like the same thing on both sides and the variables canceled. That would be like an infinite amount of solutions, or basically what you would have is really you had the same line twice, if that makes sense. So that's kind of what it looks like algebraically. These special cases you want to be on the lookout for. So if your variables cancel, just kind of your eyebrows should raise a little bit, and you should be thinking, well, I either have an inconsistent system of equations or I have a dependent system of equations. And remember those vocabulary words if you're not super familiar. Come on, you stupid iPad. Okay, there it goes. I think I'm like touching it like with my other hand and not realizing. I think it's just user error. But inconsistence where you have parallel lines, dependence where you have the same line. So if this picture doesn't make sense, that means you have the same line. It's gonna. Okay, so that's substitution. And I don't know about you, maybe you guys love substitution because you probably have done substitution elimination before. Maybe substitution was your go-to method. Good for you. I mean, you can keep doing that. I personally, I don't know, maybe it's just the way I taught. I always preferred elimination. I always thought it was a little bit faster or easier to do. I mean, I guess you can have hard problems where elimination isn't easier, but I always, if I had a choice, I pretty much always try and do elimination myself. But let's look at elimination here. So basically you want your equations to be in standard form. Your goal is to multiply or change your equations to make sure one of your variables cancels out when you add the two equations together. And then similar to kind of like what we saw in the first substitution questions, once you get one of your answers, you're going to plug it back in and solve for the other variable. So this first example is like a classic example where you just want to do elimination, because what you're going to do when you do elimination is you add the equations together. So like I can already see like y plus negative y is really just going to cancel out or be 0y. So this one's good to go. If I add these together, my y's cancel. I have 2 x's. And then we add the constants, or the right-hand side of our equations, we get 16. So if we solve, just divide the 2, you would get x equals 8. And then you can plug it into either equation. So if, I don't know, if one of them looks easier than the other, go for it. But I usually just plug it into the first one, unless I see a good reason to do the other one. But if you would solve, you would just get your y is -6. So I'm okay if you leave your answer separate, but some teachers really like you to write it as an ordered pair. But unless they tell you to write your answer as an ordered pair, I mean, I don't really see much benefit. But keep in mind, that would be the point. Like if you put both of these equations in like Desmos, for example, you would see they intersect or cross at the point 8, -6. So this would be an example of a independent system of equations because it crosses at one spot. And most of the problems you tend to get, they tend to give you like, I didn't ask you to classify, but I mean, if you're curious, this would be independent because of that. But most questions you tend to get are going to be independent. Most of the questions are going to give you have an answer. But it's not that hard to make an example of a question where it wouldn't work. You just either need to have the same equation twice, or you need to have parallel lines. And just because it's the same equation doesn't mean it's going to look exactly the same. It could be like by a different factor. Basically, if you doubled an entire equation, that's really the same equation once you solve, but it might not look identical until you kind of simplify it. But let's look at the second one. So this is an example where we need to try and eliminate one of our variables. And sorry, I've been just kind of going through it because I know we're a little bit short on time. But so for example, you want to see if one of the smaller variables is a multiple of the bigger one. So like, for example, the y's is an issue because there's nothing I can multiply 3 by to be the opposite of 20. I mean, at least like unless I want to multiply by a fraction, but that doesn't sound too fun to me. So I'm more looking at the x's. Does anyone see what we can multiply this bottom x to make it the opposite of 12x? Like what would we multiply that equation by? And good, Layla, and really, really closely, you want to make sure, yeah, you want to make sure it's the opposite. So, but yeah, you would multiply this equation by -3. And usually I just write it below or above, depending on which one I'm changing. So just be careful, make sure you multiply everything by that. So that would be this. And don't forget to even multiply like the other side and the equal sign. So it would equal -15. So now we can add these together. When you're doing this, you only look at the one you didn't change and your new equation. So we're kind of ignoring that old middle one. So we're going to add these together. So our x's cancel. We'd have 20 plus -9, so that's really 11y. And we'd have 37 really minus 15 or plus -15, so that'd be 25. Wait, is that right? Is this a fraction? Let me just make sure I didn't do my math right. Oh, that would be 22, not 25. I was gonna say, I try to not make the problems too bad. I mean, you can get fractions, it doesn't mean you're wrong, but. So we got our y, and sometimes it's like this is the part with elimination that sometimes sucks. So when you got to plug it back in and solve for the other one, sometimes it sucks a little bit more when you're doing elimination in that step. But so if I plug in 2 for y, so we'd really have 12x plus 40 equals 37. Okay, we are going to get a fraction for this one. I'm running a little bit out of space, so I'm probably going to have to erase this, but we would get 12x equals -3, or if you divide, you would get -3 over 12, or that's really just -1/4. If you like simplify that fraction. And I'm not doing a good job at modeling this because honestly, most people don't do this step, myself included, but you can plug in your y and your x into either one of the original equations and double check it works for both of them. So you can check your answers with these, but I mean, I'm guilty of it. Most people are too lazy to do that step. I mean, I know your math teachers always say you should check your answers, and some of you probably do. I bet some of you guys are better students than I was, but a lot of times we're just lazy and we skip that. And sometimes you pay the price, sometimes you don't, but keep in mind if it's like a test, you might want to take the time to plug them in. It doesn't take that long if you're not feeling super confident, but it's up to you. I mean, we've all done it. We've all had a question where your teacher's like, yeah, you should check your answer. You're like, eh, and then you miss it and it feels bad, but you don't regret it usually. I never regretted it. I don't know. All right, let's look at our last one. And I might have to erase a little bit to make sure I can squeeze this in. What's that? But one thing, if you're doing elimination and you see a fraction in one of your problems, one piece of advice, I mean, not only will it help us actually do the elimination in this question, but one piece of advice is always try and multiply your fraction out of your equation, because you really don't want to deal with fractions if you can avoid it. So it actually is going to help us solve it, because it's actually going to give us the opposite of our, well, we're actually going to see this problem's a little bit weird, but I mean, if you ever see a fraction, I would even if it's not going to help me get my elimination to start, I would try and just multiply it by 3 to start. Because what that's going to do, that gets rid of my fraction. So, because this is a lot easier to deal with. And right now I already see things they're going to eliminate, but if they still weren't ready to eliminate, I could just multiply it again. But a lot of times if you have a fraction, it's nice if you just want to avoid it. But we're going to see something weird happens in this problem. We're going to see that oh, and I messed up, I think. Like, I was trying to give you an example of another one, but we're going to see our x's cancel and our y's cancel. So you're just going to get really 0 because there's nothing left on that side. Oh, and then also look what happens here, actually. So I didn't mess up. We're going to get 6 minus 6 is also 0. So basically everything canceled out. What that means is we really had the same equation. It might have not, like, obviously it didn't look like it at first, but once you like kind of simplified all that fraction, you really see you have the same thing twice, just opposite signs, but it's still the same equation. So since this is a true statement, though, 0 equals 0, a lot of times we put IMS, which stands for infinitely many solutions. Or really what we have is this is a dependent system of equations, meaning that that means you have the same line. And I forgot to classify, but for the second problem, this would have also been, sorry, not dependent, independent, because we had one solution. But so see kind of the difference. Like if you get the same thing, that's infinitely many solutions, or if you get a true statement. But if you end up getting something that's false when your variables cancel out, that's where you have no solution. So those are kind of the special cases, just to make sure you're familiar with them. But sometimes they can throw you off if you're not expecting one, or haven't seen a question like that in a while, and you might think you did something wrong. But that just means you have one of these special cases. So, but typically most of the time you're given questions, it's probably going to be this first case, because usually they want you to be able to solve and do the process. But you can come across situations where you have either an inconsistent system or a dependent system. So that's it for the notes. And I'm sorry, I would have liked to given you guys time to like try some of these, but I was kind of low on time, so I wanted to make sure we got through the notes.